This is a new lectures about a new methodology. It's not new, it actually exists for quite some times, and this has been published in the Communication with SSM and a sequence of columns on thinking objectively. I will see the difference for you to look at it. It's called concurrent software development models or software stability models. This is part 1. This is a book on it, and actually we have other book for collection also. In response for those columns, there were too many, and a lot of them I have read answers as well. And would be the best methodology exist in the field of dealing with problem and solutions, and would be very suitable for the whole entire life cycle of any systems, of any development, or any solving problems, because it just can really help you to define the function and non-function requirement and find the ultimate solutions in this case. So let's walk through this and see. This is a few pages about me, and actually you could look at it. The objectives here is roadmaps, and this roadmaps would shows a scary movie. We're going through it to show you what we're trying to really show you in this case about this methodology. Roadmaps, this is actually like a scary movie, and actually this would really talk about the scares, which is actually a state of panic. Then define the killers, identify the killers, or this would be kind of talk about the problem. Then identify the catch the killers, which is the solutions, by the way. This is again, this is why we're going to go through this, by the way. This is again, go ahead. The first stage here of this roadmap we're talking about, as you can see, scare, general state of panic, and we then kind of really go and see what this general state of panic will be. So the current state of software engineering, current software projects are engineered for here and now. That's it. And this is only instance oriented. There is, and this instrument is going to be changing all the time. And the iteration of this change, it could be monthly, yearly, it could be after a few years, goodbye. This is going to be gone, by the way. Change in the support structure in the software market require massive re-engineering projects. And the engineering project, unfortunately, cost a lot more than in the original projects. It ended up to be the same vicious life cycle, by the way. This re-engineering cost a ridiculous amount of money. This is to show you. Then we're going to go into number 2. Software has a short lifespan. We spend a lot of money on building software. We didn't really benefit from it for a long time. And actually, some of the things too about software, as soon as you build it, it becomes no value, because again, it's unfortunately that's what the situation is. It only in some commercial application, it has value. This is again, but you still have to do upgrades and a new version all the time for any system. This is a problem too. After long software application is implemented, and this has been canceled, by the way, before completion, and this is considered to be more than a lot of money every year, billions of dollars, billions. Maintenance costs over 80% of the development life cycle. That's what one of the agency indicating that. The reality is maintenance costs more than 2,000% of the development of the software or system, by the way. So, and this is really heavy stuff. This is really a problematic, by the way. So let me give you an example. This is a very simple problem to show you the dilemma we're in and to show you exactly what we do right now. John, in 1998, this is a true story, by the way. I gave a loan to $1,000 to one of my students. He actually graduated from University of Nevada, and he been accepted for a job in New York, and he needed money. And actually, I'm the only source for him. He's from India, and actually, there is no way he could get money from anywhere. So let's say I give him $1,000. Just actually, it's a true story, but again, I'm trying to make it very simple and easy. He promised me to return it in 1998. April 1988, received an email from him asking me for extension to August 1998. In March 2002, I haven't received the money. Well, this is actually for the scenario here. I'm telling you, this is a problem. I received the money. He's one of my best students, by the way. He's a big shot now in New York, a great guy. So let me say, that's a problem. This model, it is, let me say, after giving this problem to students in software engineering class, and this is thousands of students, by the way, because I teach large classes, I received the following response. There is no problem. The people said that, this is not a big deal. Take him to court. Well, this is again, I cannot take this is our solution. It's not really a good solution. How do I take one of my best students to court? It doesn't make any sense. Kick whatsoever. I cannot kick whatsoever. He's a lot more stronger than me. Ignore it. Well, this is all the responses I got. Nobody can see the problem in this. Nobody. I'm telling you the truth. There is no one. We build software this way. Ask them about the problem space, they would not know. I'm telling you the truth. I've been a developer, I've been a professor, I did everything in software engineering. I'm an author, I'm very well known, so I'm telling you the reality here. So what do you think? Let me say, this is again a question, which is the results. There is a lot of them. The percentage was completely, there is no problem, and ignore it. This was completely 90% of the answers, by the way. They don't recognize the problem. They have no idea. Now, take him to court, okay, so this is solution stuff, and this is solution. A solution means, it's not a good solution also. I'm here trying to tell you that's the way we build software and systems, by the way, because it depends on software. Just where is the problem? That's what really the question is. So traditional models, I modeled this. You see, in the whole entire scenario, there are three classes: lender, loan, and borrower. That's it. And next relationship here is written there. Lent, this is lender lent a loan to borrowers, which is actually lender owe all the lenders this money, by the way. Do you think this model is an accurate representation of the problem? The answer is no. Believe me, that's what we really build in software. This is really, you will see. I'm going to analyze this for you to see where the problem will be, by the way. So let me go this. Now, identify the killers, the problems. The problems here, wrong analysis. Oh, we are master in doing wrong analysis all the time. Industrial objects, because we build based on tangibilities. There is no any other thing there. This is called concepts. In this case, we end up with no stable architectures, missing the most enduring words. Why did I give him the money in the first place? See, this is why this is now we have to look at this very closely. Because this is what we're doing is not, and this is again, this is nonsense, to be honest with you. Now I'm going to repeat the song analysis, which is usually what happened all the time in software development. Industrial object, we're using concepts, which is tangible, changeable, and is actually going to change over time, means this system is going to be having a short lifespan, it's going to be a maintenance nightmare all the time. No stable architecture. There is not, you cannot call this an architecture. 3 classes. This is the nonsense. In missing the most enduring words, which nobody even see in any software development, by the way. So let me see. Now, this is the problems. I'm going to go and catch a roadmap to really catch the killers. Take this problem to do analysis for it. So I'm going to ask myself a few questions here to do this. Why did I give him the money in the first place? Friendship. He's my student or my friend. So this is actually an obligation for me to do that because he need to get the job from another place. I'm his mentor. There is no question about that. There are a certain number of questions here. I will tell you other relationship. The other student, no, I know him as my student. So in my finding a solution, in this case, I have to consider all this relationship. His wife knows my wife, stuff like that. This is again, is he working? I have to really be very concerned about that. This is an exhaustive analysis of the problem, simple problem. This is again, you say this is going to take a long, no. I'm just trying to show all the aspect of really analyzing the problem here. This is it. And this is the most really you have to go through. You have to identify all the BOs and ABTs. I'm going to talk about it, I'm telling you, I told you in the beginning. So this is again, just go and see here. This is family, his family, his health, what's going on, his finance, his education. Maybe he's really working on his doctorate degree somewhere, So he might need the money more than I do. I don't know. His expense, what is his situations, his needs, very important. Now, I called him and said, listen, I know all your situation here. And I'm going to give you a schedule to pay me a certain amount of money every month or every period of time. Look at this. This is what the analysis is there. This is domain analysis. People must do this, by the way. So I end up really seeing the leaves or maybe the tangible objects, which is actually in this case would be the borrower, the lenders, and the loan. They are outside the analysis of the things I'm doing. Think about that. If you do this, you would be very successful, by the way. Now, I know this is exhaustive. There is no question about that. But the idea here, just actually show you how you do analysis here. Appear to me here, a lot of issues here. This is going to be all in the model? No. I'm doing the exhaustive analysis here to start really finding this is actually the solution for this. And this is actually the whole entire model there. I have here friendship, enduring concept. I have friends, business, object. Because again, as a class, as a whole, you're actually part of the system and you are a business object. Loan is a business object. Finance is enduring. This is a lot of enduring stuff. I'm going to concentrate only on how do I get this money. But that's it, basically. This has actually come to be, this has been designed a long time ago. So please do not really, I am one of the, thank God, I'm one of the best architects in software engineering. By the way, this is again, this has been done 20 years ago. Just an example to show you how these things look like in traditional models. That's a traditional model too, which is wrong. We have to come with a different model completely. That's why this methodology for. Anyhow, let me see. This is ABT based models, which is not yet the models I would hope for. But I will show you how the model look like. You see? Now, this is another problem about the kitchen. As I come to the United States many years ago, I found out people change the model of their kitchens every 10 years. In my culture, there is nothing like that. Anyhow, my old culture. They spend a lot of money. This is actually, they renovate the home because they want to sell it. They want to repair it for their their own kids and stuff like that. They do that. This is actually to make them the kitchen or maybe the home. This is more innovative and more new, and they really buy new stuff and stuff like that. And this is a very interesting problem because actually it happened all the time. System are kitchen are system that we are familiar with. That's another issue I understand. What make a kitchen is a kitchen? A very important question there. What make a kitchen as a kitchen? The house and the restaurant and all the kitchens in the world, they actually is instance of kitchens. And the kitchens make the home. Because again, when I go to buy a house, the woman would go in, the wife and the kids, and the only thing they look for is the kitchen. The kitchen, because the kitchen is the place everybody live in. This is again, you live in the kitchen more than you live in the house. You do a lot of stuff in the kitchens. You socialize in the kitchens. You court in the kitchens. You do everything in the kitchen. By the way, so this kitchen is a very important place. And we build millions of instances of the kitchens worldwide in the United States, by the way. Traditionally, people think of a certain set of objects when they think about the kitchen. Not what make a kitchen a kitchen. No, they just have this is their own vision, the tangible stuff, the things they see, the stove, the sink, the refrigerator, the dishwasher, the cabinets, stuff like that. So, let me say, this is what the kitchen look like. Appliance counters. This is really, this is the traditional models. It's an awful look traditional models. I know that because again, this done, and I did this on purpose. Even if you try to enhance it, it's still the same. Because again, in modeling, there is a lot of things people do which just doesn't make any sense. And actually, I have a lot of work on modeling too, by the way. But this is again, and a lot of publication on it too. So, look at this traditional model of the kitchen. This model has inherent flaws all the time from the previous models and so on. This is the same thing with those software. This is a cycle which is strange. So the model can be thought as of a tree or thought as a tree of aggregation and generalizations. As you could think of this model this way, thought to be. Many of the roots of the subtree can change drastically, causing this model to break. This is again very good, and actually this is the actual indication. So if something failed, means this is again the same. This is a traditional one, you know. For example, imagine replacing application appliance node with a start track for the replicators. This is again, it cannot be. This is that's a consideration we have to think about when we really build the kitchen. So to correct this kitchen, to correct this model, we must concentrate on those aspects do not change over time. That's one never appeared in the traditional way. We call it enduring business, which is actually they are enduring business themes. They are those words that remain constant for a given problem, never change. They are there all the time. Very important to think that way. In the second one, which is called business objects, the one which is make the enduring business theme done, achieve the EBTs, which is called an EBT, are those support objects that remain externally stable. When I say something here, internal stables, I did this on purpose. So it's supposed to be internal stables and externally adaptable. This is written in a column this way. I tried to change it, was too late. So therefore, EBTs and BOs are black box, not to be touchable. No way. But I have the freedom as a developers to, when I apply it, when I show you the application, how this has been done, I have a freedom to adapt this business object externally. And I could add to it, I could really override something, stuff like that, to make it more flexible. Object that may be replaced as time change, we call it industrial objects. And we have 3 layers here. EBTs, 1 layers, connect to BOs, which is actually the horses for achieving the EBT. Then we attach this to industrial object, which are the concepts. Both EBTs and BOs are your unified words. And as you know, any unified words has many concepts, by the way. This is the situation here. So the BOs would attach tangible stuff, the one we use for development now. We develop everything based on tangibility. Our thought and thinking and what we do in our life depends on tangible things. So you see a car, you want to love to buy a car. Even love a car, it doesn't make any sense to me. Car is just a toy to take you from one place to another. This is, you hear people say, I love the car. Yeah, this is a joke. You know, you love your kids, you love your wife, you love your God. This is again better than one. I love your God. This is, you cannot use this word this way. There are certain words people use which is not appropriate. Even in development too, by now. Anyhow, this is again, this is 3 levels now. This is what I want to work on this. Let me show you how in this problem. There are 3 questions there you have to answer to come up with this. What is a kitchen needs? No, I want to say something different in this. I have 3 questions or 5 questions. The corresponding question in the 5 question, what is the kitchen for? The first things come to your mind, cooking, right there. That's an enduring business themes. That's what the kitchen for. Now, this is kitchens. What do people do in the kitchen? socialize, socialization. This is again, try to reach everything in the kitchen in an easy way. Live in the kitchen, livability. This is a lot of different things there. Convenience, because again, if you have a kitchen, you don't have to go out and eat every time. The kitchen will be convenience for you to make anything you want. The kitchen also, some of the property has to be clean. Kitchen represent a cuisine, by the way, too, by the way, So, and in the kitchen, you cook some recipes there. Of course, if you say, this is what, do people in the kitchen, they have recipe to start cooking, stuff like that, and meals and stuff like this, correct? But would you say, here is, sorry, I'm going to go back again, because again, I didn't put the tangible stuff like the stove, the refrigerators, the freezers, stuff like that outside the analysis domain. And this would be the leaf of the models. That's why I have to build this one here. And it depends about the kitchen now. This is again, if the kitchen is small, large, I have to make it look big. Even if some of the space is small. Huh? This has a different look on things, by the way. It has to be kind of really have good airs and good environment, stuff like that. It has to be safe too, by the way. Stuff like that I could consider in any kitchen. Then I would build the kitchen as an engine, and I could build on top of it any kitchen I want to. Remember, the leaves is outside the analysis, the problem and the solution there. Remember, this is models would really expand as well. For example, I have to start with cooking. I have cuisine. Cuisine is any cuisine. For example, this would be a BO. Cooking is in an ABT. I have recipe, any recipes. And other stuff too, by the way, it's actually all industrial objects. And when I do this model this way, then I don't have to change the knowledge. This is the knowledge. This is the knowledge right there. So I'm remaining space for a storage. I have to have this so to connect to cabinet, for example. You see? So what is the kitchen for? Is actually to do, cooking and stuff like that. So to answer these questions, ignore the word the kitchen here and actually turn it out to ask a question about anything of the three questions. What does the system you're building need for? What do we need in a building is system you build for? What's the system you build for? So you know now what's the enduring concept are. So what the people actually do in this system, you start thinking about the BOs. So what really the kitchen is, a kitchen is for what? This is the IOS. To attach IOS to it, by the way. So this now, in this case here, what we did, we introduced two new layers, enduring business themes and business objects. Never been shown before in traditional models. Both encapsulate the core knowledge, which is not existing actually in tangible models, or the class diagram, or the system we're building, which is not included in traditional models, and both are unified words. It's not concepts. The leaves of the model, industrial objects, which are the concept of the unified words. For example, you have we have a vehicle as a business object. You have too many kind of vehicles exist. They are tangible. You can see it, for example. So serious need here, what I need from you, I have a proposal really to be submitted to NSF. And I'm looking for the following partners, because this methodology is going to be online for everybody to use. And the array of people going to use it is huge online, in face-to-face, in seminars, in companies. This is, again, very important to do it that way. Individuals, professionals, practitioners, academics, such universities, software organization, training company, government organization, and I would like to get endorsement letters to really support that idea of this methodology. That's what I want. This is what really serious about. This is again something we need to do. We cannot reinvent the wheels anymore. This is too much, wasting a lot of money and actually a lot of energy and a lot of time. Now, this is a book, another topic. This is almost done. We have another book also. I'm going to show it to you in the next lecture, part 2. And this is very important for you to do. If you need any more reference, please contact me. Those 4 columns written on this, I have a lot of other papers, workshops, tutorials, and other things been done on this for many years. So communicate with me. And please participate and actually become a partners or, or players in this proposals, or also write an endorsement letters to help our industry to help save what we're really going through. Stop really developing instance-oriented development, and this is nonsense. Thank you. Have a good day.